Hey everyone, welcome back. Ready for another deep dive? Today we're going to be checking out how Netflix handles all that data, all those movies and shows and millions of users.
Yeah, it's mind-blowing, really.
It is. So we've got this awesome blog post from the Netflix technology blog. It just came out this month. And it's all about it's this new system they built for handling a very particular type of data.
Right, and what's cool is that Netflix is dealing with challenges that any company working with, like, tons of data is going to face.
Totally.
You think about it, right? Millions of users around the world, they're tracking, what you're watching, when you're watching it, even, like, what device you're on.
Oh, yeah, all that stuff.
Yeah, and Netflix does it on such a massive scale that makes their solutions super interesting.
So how much data are we talking here? Like, give us a sense of the scale.
Petabytes. Think petabytes of data.
Petabytes. Okay, so that's help us out here. How much is a petabyte?
Okay, so imagine trying to store, like, every single book ever written, multiple times over. That's the kind of scale we're talking about.
Wow, okay. And it's not just about storing it. They got to analyze it all, like, in real time, right?
Oh, yeah.
So they can make those recommendations we all love, keep the streaming quality good, and make sure the whole Netflix experience is smooth.
Yeah, the whole 9 yards. It's pretty impressive.
Yeah, absolutely. So let's dig into this. How do they actually manage all that data? What's their secret sauce?
Okay, so get this. They've built something called, they call it the time series abstraction.
Time series abstraction.
Yeah. Now, before you think this is just, like, another time series database.
Right.
It's actually way more specialized.
Okay, so what makes it different?
This system is laser focused on grabbing very specific event data, like, a user clicks play on something, pauses a show, finishes an episode, stuff like that. And they also keep tabs on system events, like, let's say a server comes online or if there's like a network hiccup.
Gotcha.
So they need to capture all this in a way that's super efficient, both for storage and when they got to get that data back out.
Okay, so efficiency is key, right?
Yeah.
Especially at that scale. So how do they do it? How do they actually structure the data?
It's pretty elegant, actually. They've got this data model. Imagine, like, a filing cabinet, right?
Okay, filing cabinet. I can visualize that.
Each drawer is what they call a namespace. So it's like a container, but for a specific type of data. It could be user interactions, system events, that kind of thing.
Okay, so each drawer has a specific purpose, right?
Exactly. Then inside each drawer, you've got folders, which they call time series IDs.
Time series IDs.
These are like the timelines for a specific entity. Think of it like your user profile on Netflix. It's like a record of all the events associated with you on Netflix, your viewing habits, what device you use, and all that.
Oh, okay. So it's like a chronological history of everything I do on Netflix.
You got it. Then, inside each folder, you've got those individual documents, right? Each one representing a specific event, like when you clicked play on Stranger Things.
So each time I hit play, that's a new document in my folder.
Exactly. And each event gets a timestamp so they know when it happened, a unique ID, and then what they call event items to provide, all the juicy details.
Okay, so the event items are like what descriptions of what happened during that event.
Yeah, think of them like the bullet points on each document. It could be something like device type, iPhone, or show name, Stranger Things. It breaks down the data into these, like, manageable pieces.
Oh, that's smart. So they're not just storing like this big blob of data for each event. It's neatly categorized.
Exactly. Makes it way easier to store, retrieve, and analyze what's happening on the platform.
Okay, so we've got this well-organized filing cabinet of data, but how do Netflix engineers actually work with it? How do they get the data they need?
So for that, they've got these APIs, a whole bunch of them actually, for different tasks. Like there's one for writing new events, another one for reading specific events, and even some for searching and aggregating data.
So it's like having different tools for accessing and manipulating all the information in that filing cabinet.
Exactly.
Okay, so let's say like a Netflix engineer wants to see how people are reacting to, I don't know, a new feature.
Yeah.
How would they use these APIs?
So they'd use the right API to send those events, like, someone clicking a new button, to the time series system, all packaged up with those event items we talked about.
Okay.
And later, they could use the read API to pull back all the events for a specific user or maybe a certain time frame to see, like, how people are actually using that feature.
Gotcha.
Or maybe they want to see how many times that button was clicked across, all users in a certain region. That's where the aggregate API comes in handy.
Okay, so that gives them like a bird's eye view of what's happening.
Precisely.
It sounds like a really powerful way to analyze all that data and, actually answer some pretty complex questions about how people are using Netflix. But let's be real, storing all this information efficiently with that amount of traffic they're dealing with, that's got to be another beast altogether. How do they handle that storage side of things?
Yeah, that's where Netflix's engineering really shines. They've gone with this two-tier approach to storage, kind of leveraging the strengths of two really popular systems,
Okay.
Cassandra and Elasticsearch.
Cassandra, Elasticsearch. Okay, so these are like big names in the database world.
Oh, yeah, definitely. So Cassandra, think of that as the workhorse, right?
Mm.
It holds all those raw event records, and it's known for handling high throughput.
High throughput, meaning it can like process a lot of data really quickly.
Exactly. Tons of data coming in, no problem. And it's also very durable, so you know that data is safe and sound.
Got it. So Cassandra is like the heavy lifter, storing all the raw data. What about Elasticsearch? What's its role?
Okay, so Elasticsearch is, it's the speed demon, super fast for indexing and searching.
Okay.
So while Cassandra is great for just storing tons and tons of data, it's not ideal for like really complex searches, especially across those massive data sets.
Yeah.
That's where Elasticsearch swoops in, helps Netflix engineers find what they need quickly.
Oh, that makes sense. So they work together. Cassandra handles the bulk storage, and Elasticsearch makes it easy to find what you're looking for.
Precisely. And what's really clever is that they haven't just dumped all this data into these two systems randomly. They've got a specific partitioning scheme to keep it organized.
Partitioning scheme. Okay, I think you mentioned this earlier, right? It's like that filing cabinet analogy.
Exactly. They've used their data model, with the namespaces and all, to create this multi-layered partitioning scheme, make sure no single part of the system gets overwhelmed.
Okay, so how does that work? How do they actually divide up the data?
They start with what they call time slices. Essentially, chunks of data based on time intervals. Could be a week, a month, helps them manage the data, maybe archive older stuff.
Okay, so time slices are like the big picture divisions.
Right. And then within each time slice, they've got smaller units called time buckets. Those might be like hourly or daily chunks, depending on the type of data.
Okay, so time slices, then time buckets within those. Got it.
But what about those sudden spikes in traffic? When everyone's trying to watch the new season of Stranger Things all at once, how do they handle that?
That's where event buckets come in. These are within each time bucket. Think of it like having subfolders. So even if 1 million people hit that play button at the same time, the system can keep up.
Okay, so it's like having multiple lanes on a highway so everything keeps flowing smoothly, even during rush hour.
Exactly. And this whole partitioning thing, it's all about preventing this nasty problem that often happens with large databases. It's called a hot partition.
Hot partition, that sounds kind of scary. Yeah. It's not good. It's basically when way too much data ends up in one partition.
Okay.
Creates a bottleneck and slows everything down. But by dividing the data this way, they avoid that problem. Keep everything running smooth.
That's clever. So they're spreading the load, making sure no one part of the system gets overloaded.
Yep. And this approach works really well with their choice of Cassandra and Elasticsearch. Both of them are designed to scale horizontally. So as Netflix grows and gets more data, they can just add more servers to handle it.
Makes sense. It's like building a house with expandable walls. As your family grows, you can just add more rooms.
Exactly. And the Netflix team has built in a lot of flexibility so they can actually adjust their partitioning scheme over time, to adapt to changing patterns.
Wow. So it's like a self-tuning engine.
Yeah.
Constantly adapting to ensure everything runs smoothly. This is starting to sound pretty complex, though. How do they manage all this behind the scenes? How do they configure everything?
That's where the control plane comes in. Think of it as the brain of the whole operation.
Okay, the control plane.
Yeah, it manages all the configuration settings, makes sure data's flowing between Cassandra and Elasticsearch, and that the whole system's healthy.
Okay, so it's like the conductor of an orchestra, making sure everyone's in sync.
Exactly, and it's separate from the data plane, where the actual data processing happens. That way, it's more reliable.
Okay, so they've separated the management from the actual data processing. That's smart. But I'm curious, what kind of control does this control plane actually give Netflix engineers? Can they, like, really fine-tune how the data is handled?
Oh, absolutely. It's super configurable. Like the blog post shows a little snippet of their configuration file, and it's mind-blowing how much they can tweak.
Give me an example. What kind of things can they adjust?
Oh, all sorts of things like the size of those time slices, the number of event buckets, even the consistency level for reads and writes.
Consistency level, what does that mean?
It's basically how strict the system is about making sure all the data is perfectly up to date.
Oh, okay. So they can, like, choose how much emphasis they want to put on speed versus accuracy.
Exactly. It lets them tailor the system for different types of data and different needs.
Wow, so they've designed this incredible, powerful system that can not only handle these massive amounts of data, but it can also be, like, custom tailored for different situations. That's pretty impressive.
Yeah, and it's not just some standalone project. It's part of this much larger data platform at Netflix that's been, meticulously designed for growth and adaptation.
It's like they built their data infrastructure to be as flexible as their content library, right?
Yes.
They're constantly adding new shows, new movies, and the system can just handle it all.
Right, and they're always looking for ways to push the boundaries, optimize for performance, and of course, keep costs down.
Yeah, because let's be real, storing and processing all this data can't be cheap.
Not at all, but they've done an incredible job of making it both powerful and cost-effective. It's really remarkable.
Okay, so they figured out the storage part. But it's not just about brute force scaling, right? They've also incorporated some really smart design principles to make sure the system is as efficient as possible.
Absolutely. And these design principles are really at the heart of how Netflix achieves this crazy performance and reliability. It's not just about throwing more servers at the problem. It's about being smart about how you design the system itself.
Okay, well, let's dive into those design principles. I'm dying to know how they make it all work so seamlessly. What's the first one that stands out?
One of the key ones they highlight is event idempotency. Might sound kind of intimidating.
It does sound a little technical.
Yeah, but it's a pretty simple concept with some big implications.
Okay, break it down for me. What is event idempotency?
Basically, it means that if you send the same event to the system multiple times, it only gets processed once.
Okay, so it's like hitting the send button on an email multiple times. You only want the email to be sent once.
Exactly. That's a great analogy.
Okay, that makes sense. But how does this help Netflix? Why is it so important for them?
It's crucial for handling things like retries, which happen, when a request fails for some reason. Imagine there's a network blip and an event doesn't reach the system. With idempotency, they can just resend the event without worrying about messing up their data.
Gotcha. So it's like a safety net, making sure that even if things go wrong, the data stays consistent.
Exactly. And it also plays a key role in their hedging strategy.
Hedging. Okay, now I'm really intrigued. What's hedging all about?
Think of it like this. They actually send out multiple copies of the same request. They're hedging their bets to make sure at least one gets through quickly.
So it's like sending multiple pigeons with the same message, just to be sure that at least one of them gets to the destination.
You got it. It's all about speed and making sure things run smoothly, even when there are hiccups.
Okay, that makes sense. So they're not just relying on one request getting through, they're sending out backups. It's like a built-in redundancy.
Exactly. And this idempotency thing works hand in hand with another principle they call SLO-based hedging.
SLO-based hedging. Okay, you're going to have to explain that one. What's SLO stand for?
SLO stands for Service Level Objective. Basically, it's like a target for how fast a particular operation should be completed.
Okay, so they set a time limit for how long it should take to, say, write some data to the system.
Exactly. And if it takes longer than that,
They hedge it. They send out another request to try to get a faster response.
you got it. It's like having a backup plan for every request, just in case things get bogged down.
I like it. It's like they're constantly pushing for speed and efficiency.
They are. And then, get this, they've even got a system for those situations where you absolutely need a response quickly, but you're willing to settle for a partial one.
Okay, so sometimes you don't need the entire data set right away.
Right. They call it partial return.
Partial return.
Yeah.
Interesting. So when would they use that? Give me an example.
Think about something like trying to limit how many times a user sees a particular ad.
Okay, yeah.
You need to know how many times they've seen it recently, but if that request takes too long, the ad might already be displayed, and then it defeats the purpose.
Right, so in that case, getting a partial response with whatever data is available immediately is better than waiting for the complete data set and missing the boat. It's like a good enough approach for time-sensitive
Yeah,
situations.
exactly. And they apply a similar approach to pagination.
Pagination, remind me, what was that again?
Remember how they break down large datasets into smaller chunks or
Ah,
pages?
oh, right.
Well, with what they call adaptive pagination, the system adjusts how much data is fetched at once, depending on how the data is being accessed.
Okay, so if most requests are only looking at the first few pages,
Mm.
they don't waste time fetching the rest.
Exactly. They're optimizing every step of the way.
It's like they've thought of everything. They're really squeezing every bit of performance out of the system.
They really have. And remember, it's not just about how quickly they can access the data, but also about how they manage the data itself once it's in the system.
Okay, so let's talk about that. How do they manage all that data once it's stored? What kind of like housekeeping do they do?
Well, one key principle is what they call the limited write window. Essentially, there's a time limit for how far back in the past you can write data.
Okay, so you can't just write data from like 5 years ago.
Right. This helps make sure that most of the data becomes immutable relatively quickly.
Immutable meaning it can't be changed.
Exactly. And this lets them make some cool optimizations, knowing that most of the data is basically set in stone.
Oh, I see. So it's like saying, okay, after a certain point, let's optimize this data for reading because we know it's not going to change.
Exactly. It's a smart way to improve performance.
Okay, that makes sense. But what about those bursts of writes we talked about earlier? You know, when a new season drops and everyone's hitting that play button. How do they handle those sudden spikes in incoming data?
Ah, they use something called buffering rights. Think of it like a shock absorber for the system.
Okay, so instead of the data hitting the database directly, they're queuing up those writes and then processing them in batches.
Exactly. It's all about smoothing out those spikes and preventing overload.
That's clever. So they're buffering the writes, and then once the data's in the system and it's not being actively written to anymore, what happens then?
Then they've got another trick up their sleeve: dynamic compaction.
Dynamic compaction. Okay, that sounds intriguing. What is that all about?
Imagine you've got a messy room, right?
Uh-oh.
Dynamic compaction is like tidying up and reorganizing that room. Once the data is not being actively written to, they go through, clean it up, optimize it for even better reading performance.
So it's like decluttering the data,
Hmm.
making it more efficient to access.
Exactly.
Wow, so they're constantly optimizing, even after the data's stored. All of these design principles working together, that must result in some pretty impressive performance, right?
Oh, absolutely. The blog post says they can hit write speeds in the single-digit milliseconds.
Single-digit milliseconds. That's like instant.
Right. And even more impressive is that they maintain really stable read speeds, even when the system's under a heavy load.
That's incredible. And remember those 10 million writes per second we talked about earlier?
Yeah.
Well, they're actually handling even more than that now. At the time they wrote this blog post, it was something like 15 million events per second across all their data sets.
It's mind-blowing. They've really built a powerful and efficient system.
Yeah, they really have. So we've covered a lot of ground here, from their data model to their storage secrets and these really fascinating design principles. But, you know, at the end of the day, how is Netflix actually using this time series abstraction system in the real world? What are some concrete examples?
The blog post actually highlights several key use cases, shows just how versatile this system is.
Okay, so like how are they using it? Give me an example.
One of the use cases is tracing. They use time series to track requests as they move through their system architecture, gives them insights into performance bottlenecks, potential issues.
So it's like having a detailed map of their entire infrastructure, allowing them to quickly identify and fix any problems.
Precisely.
Okay, well, that's
Well, of course, they use it extensively for tracking user interactions. Everything you do on the platform is captured.
so my late-night Stranger Things binge-watching sessions are being meticulously tracked and analyzed.
Every click, every pause, every rewind. And they use this data to personalize recommendations, making sure you always have something new and exciting to watch.
So it's like they're building a personalized TV guide for each user based on their viewing habits. Pretty cool.
Yeah, and it goes beyond that. They also use time series to track feature rollouts, so they can see how people are interacting with new features.
That's smart. So they're using data to make decisions about what features to keep, what to improve, and what to maybe scrap altogether.
Exactly. It's like having a giant A/B testing platform baked into their infrastructure.
Fascinating. What other applications are there?
They even use it for asset management, tracking their massive content library.
Oh, right. They got to keep track of all those movies and shows.
And then there's billing and subscriptions, all that information about payment history. Plan details, all managed through time series.
So it really is a core part of their infrastructure, touching almost every aspect of their business. And the best part is, they're not done yet. The blog post hints at some exciting future enhancements they're working on.
Oh, absolutely. They're always pushing the boundaries, looking for ways to make the system even better.
Like what? What are some of the things they're working on?
Well, one of the things I mentioned is tiered storage. Remember how we talked about using different types of storage for different types of data?
Oh, yeah, yeah. Using faster, more expensive storage for frequently accessed data and cheaper, slower storage for the stuff that's not used as often.
Right. And the blog post suggests that this could potentially save them like millions of dollars.
Wow, that's a huge saving. It just goes to show that even small optimizations can have a big impact when you're operating at Netflix's scale.
Absolutely. And another enhancement they're exploring is dynamic event bucketing.
Dynamic event bucketing. Remind me what that was again.
Remember how they divide the data into time slices, time buckets, and event buckets?
Oh, yeah, yeah.
Well, with dynamic event bucketing, they want to make those divisions more adaptable. So instead of having a fixed number of event buckets, they could adjust that number on the fly based on the traffic patterns they're seeing.
So it's like adding more lanes to a highway during rush hour to keep the traffic flowing smoothly.
Exactly. It would help them prevent those hot partitions
Mhm.
and ensure that the system can handle even the biggest spikes in activity.
Smart. So they're not just building a system for today, they're building a system for the future, a system that can adapt and evolve as their needs change.
Exactly. And they're also looking at how to leverage improvements in newer versions of Cassandra, which are better at handling wider partitions. That could potentially make their system even more efficient.
It sounds like they're constantly evaluating new technologies and looking for ways to make their system even more robust and efficient. It's like they're fine-tuning a high-performance engine, constantly looking for ways to squeeze out a little more horsepower.
That's a great analogy. And they're not stopping there. They're even considering incorporating caching to further optimize read performance.
Caching. So they're going to store frequently accessed data in a faster, more accessible location, so they don't have to keep going back to the main storage system every time they need it.
Exactly. It's like keeping a cheat sheet handy for those commonly used formulas. You don't have to look them up every time.
Makes sense. So they're really optimizing every step of the way. It's like they've thought of everything.
They really have. And it's all in the service of providing that smooth, seamless experience that Netflix users expect.
Well, I'm really looking forward to diving deeper into some of these design principles and seeing how Netflix applies them in different scenarios. I think there's a lot we can learn from their experience.
Definitely. There's still a lot more to unpack.
Stay tuned, everyone, as we continue our deep dive into the world of Netflix's time series abstraction in part 2.
It's crazy, right? How much we rely on these systems, these like super complex systems. We just hit play and expect to like instantly watch anything we want, but behind the scenes, it's a whole other world.
Yeah, it's easy to forget about all that data, all those systems working to make it happen. And, what's really cool is that Netflix isn't just like throwing more servers at the problem. They're always looking for smarter ways to do things.
And they're willing to share those solutions. Like in the blog post, they talk about some enhancements they're working on, things like tiered storage.
Tiered storage, right? We touched on that briefly before. It's about using different types of storage for different types of data, right?
Exactly. It's all about finding that balance between cost and performance so they can keep the data that's accessed all the time, the hot data, on the fastest storage, even though it's more expensive. And then the older stuff, the cold data, can go on cheaper, slower storage.
So it's like in your house, you keep the important stuff you use all the time, like close at hand, and then the stuff you rarely need goes in the attic or the basement.
Exactly. Makes total sense, especially when you're dealing with petabytes of data. Like, why pay top dollar for speed on stuff you barely ever access?
Right, right. And how much do they think they can save with this tiered storage approach?
The blog post mentioned something like millions of dollars potentially.
Millions. That's wild. Just goes to show even small tweaks can make a huge difference at that scale.
Oh, yeah, for sure. And another thing they're working on is dynamic event bucketing. Remember how we were talking about time slices, time buckets, and event buckets?
Yeah, yeah, like dividing the data into smaller and smaller chunks.
Right. So with this dynamic approach, they want to be able to like adjust those divisions on the fly depending on how the data is being used.
So instead of having a fixed number of buckets, they could like automatically add more during those peak traffic times. Kind of like adding more lanes to a highway during rush hour.
Precisely.
Yeah.
That way, they can prevent those hot partitions and keep everything running smoothly, no matter how much traffic is coming in.
Super smart. And it seems like they're always keeping an eye on new technologies too. Like, what about the new version of Cassandra?
Oh yeah, Cassandra 4.x, right. They mentioned they're looking at how they can take advantage of the improvements in that version. It's supposed to be much better at handling wider partitions, which could make their system even more efficient.
So they're not just building a system for today, they're building a system for the future,
Mm.
constantly adapting and evolving.
Exactly. And they're even thinking about incorporating caching to make those reads even faster.
Caching, right. That's where they store frequently accessed data in a faster location, like memory, right? So they don't have to go all the way back to the main storage every time.
Exactly. It's like keeping your most frequently used tools right on your workbench so you don't have to go digging through the toolbox every time you need them.
Makes sense.
Yeah.
So they're optimizing at every level. It's
Yeah.
really impressive. But, it's not just about the technology itself, right? It's also about the people behind it, the culture that allows this kind of innovation to happen.
That's a great point. And you can really get a sense of that culture from the blog post. It's a culture that really values experimentation, collaboration, and pushing the boundaries.
They're not afraid to try new things and to share what they've learned, even if it didn't work out perfectly.
Exactly. And I think that's a big part of what makes them so successful. They're constantly learning and iterating, always striving to improve.
It's not about being perfect, it's about being willing to learn and grow.
Right. And they've created this environment where people feel comfortable taking risks and sharing their knowledge. That's really powerful.
And it probably helps them attract and retain top talent too, right?
Yeah.
Who wouldn't want to work in an environment like that?
Absolutely. It's like they're saying, come work with us and let's solve some of the most interesting challenges in data engineering.
And they're not just keeping all this knowledge to themselves. They're sharing it with the world through blog posts like this.
Exactly. It's a win-win. They help raise the bar for the entire industry, and they get to showcase their expertise.
It's a really smart approach. So we kind of wrap up this part of our deep dive. What would you say is the key takeaway for someone who's just starting to deal with, like, the challenges of big data? What can they learn from Netflix?
I think the biggest thing is to not be intimidated by the complexity of the problem. Break it down, understand your data, your requirements, and then explore different solutions. Don't be afraid to experiment, to try new things, and to learn from your mistakes.
It's all about embracing the challenge and being willing to learn and grow. And who knows, maybe someday you'll be sharing your own data engineering insights with the world.
That's the dream. It's a really exciting time to be working with data. There's so much potential, and the tools and techniques are constantly evolving.
It's like exploring uncharted territory, pushing the boundaries of what's possible with data. And Netflix is definitely leading the way, showing us what can be achieved when you combine, smart engineering with a culture of innovation.
Absolutely. They've built a system that's not only incredibly powerful, but also um, adaptable and efficient. And they're constantly pushing the envelope, finding new ways to optimize and improve.
They're not just building a better streaming service, they're pushing the whole field of data engineering forward.
I love that. That's a great way to put it.
Well, I'm excited to dive into the final part of this deep dive, ready to explore some more of the amazing things Netflix is doing with their time series extraction.
Let's do it.
It's funny, as we've been going through this blog post, I keep thinking about how much of what Netflix is doing, it kind of reflects like the bigger picture of software development these days.
Sure, definitely.
This focus on building systems that are like super adaptable, scalable, resilient. It's like a recipe for success in this world of cloud computing and these like massive data sets.
Yeah, and one thing that stood out to me is how they've designed these systems to not just, handle success, but also failure.
Failure.
Yeah, like they understand that in these complex systems, things are going to go wrong, right?
Yeah.
It's inevitable.
Right.
So they've built in these like mechanisms to handle those hiccups without the whole thing crashing down.
It's like they've accepted that things will break and made the system flexible enough to bend without, snapping.
Exactly. And a big part of that is automation, right?
Oh, yeah. Automation. Tell me about that.
They've automated so much of their infrastructure. I mean,
Yeah.
everything from like spinning up new servers to scaling resources and even optimizing that data storage.
So it's like freeing up their engineers to focus on the bigger picture stuff, right?
Yeah.
Instead of just like constantly putting out fires.
Exactly. It's almost like a self-driving data center,
This driving data center, huh? I like that.
Yeah, it can like adapt and respond to changes without, needing someone to constantly babysit it.
That's got to be a huge help when dealing with, like, those massive traffic spikes, right? Like when a new season drops.
Oh, absolutely. When everyone's, rushing to watch the latest episode, the system just scales up automatically to handle the load. Then when things calm down, it scales back down. That kind of agility wouldn't be possible without a lot of automation.
That's incredible. So it's not just about the technology itself; it's also about the people behind it, right? The culture that allows for this kind of innovation.
Yeah, and you really get a sense of that culture from, reading this blog post. It's clear they value things like experimentation, collaboration, and just a general willingness to push the boundaries.
They're not afraid to like try new things and to share what they've learned, even if it didn't work out perfectly.
Exactly. And I think that's a big part of what makes them so successful. They're always learning, always iterating, always trying to, improve.
It's not about being perfect; it's about being open to learning and growing.
I love that. Yeah, and they've built this environment where people feel comfortable taking risks and sharing their knowledge, which is really powerful.
Yeah, absolutely. And it probably makes it a lot easier to attract and keep, really talented engineers.
Oh, for sure. I mean, who wouldn't want to work on these kinds of cutting edge projects?
Right. So as we wrap up this deep dive into the time series abstraction, what would you say is like the biggest takeaway, especially for someone who's, maybe just starting to grapple with big data? What can they learn from Netflix?
Don't be afraid of the complexity. Break it down into smaller pieces, understand your data, your requirements, and then just start exploring different solutions. Experiment, try new things, and don't be afraid to fail.
It's all about embracing the challenge, right?
Yeah,
And who knows, maybe someday you'll be sharing your own data engineering insights with the world.
that would be amazing. It's a really exciting time to be working with data. There's so much potential, and the tools and techniques are like constantly evolving.
It really is. It's like exploring uncharted territory, pushing the boundaries of what's possible. And Netflix is definitely, leading the way, showing us what can be done when you combine like smart engineering with a culture of innovation.
Couldn't have said it better myself.
Well, this has been a fascinating deep dive. Thanks for joining me. And until next time, happy data diving, everyone.